This module covers command definitions, and we're basically focused on how to define a new command and the components of that definition. We're looking at component levels and how they impact overrides, wrappers, that sort of thing, and actually take our first step into overrides, wrappers, and triggers. So ultimately, as the product exists on the system, the component levels are organized by directory. So commands are organized by directory. Think of a component level as a namespace. That's the way I think of it. So the discrete has a bunch of namespaces that it uses, and it makes the decision about how it's going to do that. Typically, you will have something called intrinsics. That's going to be, for a product, that's going to be the main keeper of the large portion of the functionality. Namespace permits you to, or these component levels permit you to define override flow. And so it's defined on basis of the sequence of the of the component level. So in order to overrides, command names must be identical. Override is automatic. If you call something move inventory at a level that is closer to the user than the intrinsic level, it's going to call your function rather than your component rather than ours. Some things that I find problematic about when people do the basic component substitution. This actually was the very first thing that you could do in DCS. Back in the old days, we didn't have triggers. The thing that we thought was the most advanced thing, look, you can substitute this component for this component, change out the functionality, and which was a really good first step. But what we saw is, and I still see this somewhat, is the danger in that is we were talking previously about what makes a component. Component has a couple different contracts. A contract for interface and a contract for functionality, right? So the contract for interface really specifies the minimum stuff that can be in context in order for the thing to run. Okay? The contract for functionality is, it's going to move stuff. Move inventory is going to move stuff. All right. Now, what can happen, though, is in order for us in real life to say, we're going to keep upgrades moving forward, we're going to allow the stuff to us to substitute, you must look at the component you're substituting and never go less data elements than the component is publishing. So if the component publishes 5 things, and you substitute that component, you must return those 5 things. You can return 10 other things, fine, that's fine, but you must return those 5 things. I see this happening periodically in our VB programs blow up because when they're calling components, they're tied to kind of a component. We had, back from the way back days of DCS, we've had this approach to say, once we publish an interface, that means release it as a GA, we will never, take arguments away. We will add arguments, but we'll not take arguments away in order to maintain this forward compatibility thing. So if you start substituting components and taking arguments away, pretty likely that things will start blowing up. All right? So you must, if you do this, you must do this. So this is the basic thing, is you could override a component with your own name, and essentially what you're doing is you're keeping the interface, changing the implementation, but maintaining kind of the same contract for functionality. Minimum, if you look at the contract for functionality as a minimum, you're keeping it in the same vein. So here we have what we like to call the wedding cake slide. And so the whole idea behind this is that as you go away from the center, you can add more component levels. And if we find it on the outside first, we're going to use it there. Otherwise, we're going to go further in toward the center, to the chewy center of discrete, and find it in there. And then we'll use it. The nice thing about this is, as we do upgrades, we'll be able to go ahead and put a new set of componentry in and nothing has changed. So you all know this. This is the core idea behind how discrete works. So we have this nice little program for defining commands. Ultimately, there's some variations of how you can do the command, create the command. Predominantly, most people are going to do one of two things. Make a local syntax command, which is the preferred thing to do. And if you can't do it with local syntax, sometimes you'll need to do a C component. So all of those things are available in the maintenance program, looking at the different component levels, creating new component levels, and then making components within those component levels. Ultimately, what happens is we create XML files that are stored on the server. Now, we used to actually store all the commands in a database, which was a little bit nicer from the perspective of kind of how to look at them. And the problem is that MOCA doesn't need a database to run. Well, we have MOCA installed on servers that are just doing material handling interface jobs, right? No database. Just got some server functions on there that are talking to the integrator, doing material handling stuff. No database needed. So we had to free ourselves from this database thing, and the only way to do that is to use the file system in reality, in our opinion. So one consistent thing you always have on an operating system is a file system. So here what we've got is we've got the XML set up for a component level, very basic. Basically, it's a name, description, and a sequence. The command itself, again, in XML. If you have the server command maintenance program available to you, I would recommend that you use it. The thing to realize about the server command maintenance is it's stateful. Okay, so if you add a command and go and reload memory and try the command inside of the framework, inside of the application, pretty likely you won't see it. Because as soon as you go into server command maintenance, you create state. It keeps you locked into that server process. So if you're going to be doing that, either go into WinMSQL or create another instance, open up another instance of your discrete client so you can run. The state of server command operations stays in place until you shut it down. And depending on what version, up till 2005 too, and I don't know if this is fixed, it didn't seem to ever give your state back once you went into server command maintenance. So be aware that if you're in server command maintenance, you might become stateful and stay stateful for the rest of your session. So here we've got the command definition. Here in this case, it's a C function, and the function name and arguments. Pretty basic stuff here in terms of how the command gets defined. The basic elements are name and description, type, which is going to typically be C function or local syntax, and then the corresponding elements that go along with that type. So in this case, arguments. If it's local syntax, you will actually see the actual local syntax in block inside of the definition. You also see sections at the bottom revolving around documentation. We really like the ability to do as-built documentation. The easiest way to do as-built documentation is to put good comments in here and allow us to use the capabilities of MOCA to create its own documentation to essentially create the as-built component documentation for the customer. Can't do that if you don't put the information in here regarding documentation. So component trigger needs to be differentiated from a database trigger. A lot of times when we talk to IT folks, we say trigger, and they instantly think in their minds a database trigger. So when we talk to folks on the outside world, make sure we understand that we're talking about a component trigger when we say triggers, we're always talking about component triggers. Right? There actually are potentially times where you will use database triggers, but in our mind, attaching something to the database as a trigger is too low of a level to be putting application logic, right? There are reasons to do that. You know, you might not be able to get into something at just the right level, and you might have to get in there. It's pretty infrequent. It ought to be pretty infrequent to get in there and have to do a database trigger. Do I see it? Yes. You know, is it always called for? Yeah. You know, it's kind of questionable. I typically find that with people that are new to MOCA but have good understanding of database triggers. Triggers are one of the most powerful mechanisms for customizing. Basically, they fall into two different kinds of categories: extending components functionality and tying functionality to some kind of logical or physical event. I suppose you could say that those are the same. I like to differentiate because this idea of tying functionality to some event happening in the facility is the key idea behind MOCA. If you think about it, ultimately, you could think of a facility as a series of actions and events, right? So an event, I'm placing a pallet in a P&D location. That event causes the action of somebody being called over to do the put away, right? So the whole notion behind MOCA is this idea of events and actions. An event causes an action, which causes another event, which causes another action. An action causes a sequence of events, which could cause other actions to occur. As soon as you start to get product in motion, if you start to think about your system as not just, oh, this receiving thing and this thing over here, as a set of events and actions that are tied together, now you're thinking the way MOCA wants to think. You want to think about things as events and actions. So the power of the triggers is really derived from our ability to do context. So we've talked about context in previous modules. So in this case, we place a trigger on the move inventory component. Now, the move inventory publishes a lot of information. The handiest pieces of information about move is that it always sends in the source and destination, right? Because you don't need to give it the source when you call it. All you need to do is tell it where you're moving it to. The handy thing about move is that it does come back with both the source and the destination. So it'll give you the source and destination location and the source and destination area. And those are made available in terms of triggers. So again, when we were talking before in the previous modules about how to be a good citizen in terms of doing local syntax, being good about understanding what somebody might need if they're sitting on the back of your component is an important thing. So based on this, for instance, source and destination area, I can decide what I want to do next. Wrappers, some people called pre-triggers. We initially called them pre-triggers when we were coming up with the concept, and I think the name sort of still stuck. I prefer to think of them as wrappers because they actually do wrap underlying implementation. They do allow you to get in ahead like you would think of a pre-trigger, okay? But you are operating kind of in the context of if you're substituting, you aren't substituting, you're augmenting, but you're augmenting around this component. A wrapper, again, uses this idea of our ability to manage levels of components with the same name. And it performs some functionality and then calls the next component with this name in the order that your sequences are defined. I think the important thing to realize is that it calls the next implementation. So what we're doing is we're saying we're wrapping the implementation of this. We've already done the interface work. MOCA knows exactly what it's going to send you because if you're wrapping something, you haven't changed the interface. What you've done is you've said, I'm going to do some work, and then I'm going to call somebody else's implementation of this component. And that somebody else's is whoever's defined next. Typically, I mean, every once in a while I will see something that is defined at the user at the site level, then defined at the product at our level, the var level, the VC level, and then also defined at the intrinsic level. But typically it's two. So I mean, typically it is two different versions. So you're going to probably just call the underlying product version. So this idea of this caret command name allows you to say, I'm going to call the next available version. So in this example where we are basically saying there should actually be a comment there, but if the num code is a doc num, then we're going to generate a bill number. Otherwise, we're going to just do a generate next num. So essentially what they've done here is they said, we're going to call generate next number, and the num code is doc num. Or if the num code is doc num, then we're going to generate a bill of lading number. Otherwise, we're just going to call the next thing. So it allows us to go in there and say, in a doc num, a lot of times you'll have check digits in there, and generate next number does not typically do that. It's just a handy way just to use the same thing that we always do from an implementation perspective. So trigger files. Files that are sitting in the command definition directories with mtrig, mtrg, will be picked up by MOCA as triggers. They should have the following form: component name -trigger name.mtg. If you use server command maintenance, which you should be using, it'll happen automatically. For those of us who don't do that, you just have to be cautious, because if you don't do it right, what will happen is server command maintenance will run, and then it'll write them out the way it thinks it needs to write them out, and then you'll have two versions of that trigger file out there. Let's see here. So basically, if you go in here and get into the file itself, here's what the thing looks like. It's name of the trigger on command, and then you put a firing sequence, and then the syntax. Now, I am not a huge fan of having a lot of syntax inside of a trigger statement. I've seen it. I've seen like 2 pages of code inside of a trigger statement. I think it's easier on everybody if your trigger basically calls another command. Maybe does a few if tests, does some things. But if you got 200 lines of code inside of a trigger, I think that's probably not the best practice. It's a little easier on everybody, I think, because then we can go in through and we could say, okay, here we just have to work on this one command as opposed to trying to track down the trigger. I think it just makes more sense. I don't know, have we adopted that as a preferred thing to do? I guess that's my personal preference. I mean, whatever that means doesn't really mean anything. It's just how I would like to see it and how I do it. And then when you look it up in server command maintenance, you can actually see, oh, this trigger is doing this command. If you go in there and look at the triggers and then you say, if blah, 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 it's hard to see using server command maintenance kind of what's going on. If you just have nice little syntax in there, that calls a different command. It makes it a little easier to look at for everybody. The cool thing about triggers, in my opinion, is the thing that it most does is it really allows us to enforce these sort of immutable business rules, but not in the application, but on the server. Intrinsically, we can enforce these business rules. So here's just a very simple thing. You could say, let's say that you've got a part family named Hazmat, and then you only want that product put into areas equipped with special fire extinguishers, right? Now, you could certainly use allocate location rules to stop people from allocating locations. Will that stop people from moving up? No, it just won't. It will mean that we won't select a location there. Could somebody pick it up with an RF unit and say, oh, I'm just going to put it here and then try and put it there? Yeah, absolutely they could. But if you wanted that rule to be part of the system that nobody could break, no matter if they went in with an RF, they went in with stock transfer, they went in with any other application that uses move, you need to think about this as a trigger. So this allows you to say, I'm going to create this business rule, and we're going to make this immutable thing that says, look, no matter who's doing it, no matter what the conditions, if I see this condition arise, I'm going to say, so sorry, I'm not going to let you do that. So in this case, what we could do is very simply say, look, we could keep a list of areas that have those fire extinguishers, either by putting an attribute on the area master or just putting a set of policy values out there to say, here are the areas that are equipped with these special firefighting equipment. And then in our trigger, it'd be very simple. We just look up to say, we'd look to see what got moved. We'd look up the part for that. If it's one of these parts. Now the thing about move is that it's hard for move to tell you a lot about the part, because like if you have a multi-part pallet, so when you're moving inventory and you have to get down to the part level, you have to do a little bit more work. So you'd have to actually go and see how you're moving and then grab the inventory and look at the parts potentially. But it still would be a pretty trivial thing, right? You'd go and you'd say, okay, what are the inventory you got, because move publishes a load sub and a detail. You could take a look at that and say, oh, well, there you go. It's one of these things. It's in this part family. Am I going to one of the areas that is set up to handle this fire extinguisher? And then what you could do is just return an error. All you need to do is return an error, put the code into the catalog, in the message catalog, and nobody needs to do anything else. Everybody else will have to live by the same rules. So this is why we ultimately, we're always looking for, and you as developers, if you find things that you said, well, boy, it'd be sure handy, I could do this in local syntax versus C if I had this one thing. Several years ago we said, we were missing a really fundamental capability, and that is to set the return status ourselves. So we could actually say, we found this condition, set the return status. That's why the set return status command is pretty valuable. So you can actually set your return statuses. I would say that if you're going to make up your own return statuses, it's really good practice to make sure that the user just doesn't see, 5610, got a 5610 error. So triggers versus wrappers. I get this question all the time. When should we use a trigger? When should we use a wrapper? I think that most situations are pretty obvious. I don't really know what's happening until after it happens, because move can be called in a bunch of different ways and that sort of thing. There are some situations where you want to get in there ahead of time, and if, for instance, so sometimes what we'll do is on the create order line component, we like to get in there a little ahead of time sometimes, because we can alter the data that goes into the create component and actually do, if you want to do some very simple part substitution, sometimes what will happen is the customer will send you some alternate part stuff on the order line, and then you have to kind of make a decision. Well, I actually like to do that before I actually write any data. So we've had a couple systems where we'll actually do some alternate part stuff prior to us actually calling the create order line, so we know which part number to put on the order line. So they'll send us a list of these part numbers as VC columns in their data, and we'll make some decisions. Boom, it's nice. It's a little bit more efficient than writing the data and then going back and re-updating it. So there is some advantage there. But it's not always easy to tell what's going on. So we've talked about this in previous modules. The thing about a component is preconditions, contract for functionality, post-conditions. Okay? Preconditions are really hard to understand and predict. Post-conditions are concrete. And if your component is doing a good job returning the results to you, post-conditions give you the information. So, for instance, we had somebody putting they were saying, well, we don't want to put more than one ship ID onto a load, right? Okay, so they did all this stuff in this move wrapper to do it ahead of when the move happened, and they were having to test for, okay, am I coming in with a source load? Am I coming in with a destination load? Do I have a load? Are they coming in with part number? All this stuff, all those preconditions, the way the thing is called, the state of those are really hard to predict. I mean, move can be called in about a trillion different ways, right? So, yeah, it could have been more efficient from a data perspective, maybe. But think about it this way. The 5 times a day that you got to stop somebody from doing that, those are the 5 times that you're going to actually have to do a bunch of work, right? So all of that code, which is like 2 pages, we substituted with one select as a trigger, basically to just selected a count of distinct ship IDs on the load after, we got the post conditions, we know what the thing is, move tells us, it does a good job of saying, here's your load, here's your source, here's your destination. We grabbed the load number, did a count. So all that 50 lines of code turned into one select that we were able to put on as a trigger. Right? So that is much more maintainable and predictable, right, in the long run than trying to do all this stuff in the pre-trigger. Right? So you have to choose your battles. Remember, preconditions are hard to predict. You can get some efficiencies, like if you have a very contained thing, like my example where it's going to come in, we're doing order line, a create order line, we've got these 5 little things that we have to make decisions about. Boom, there's no context change, there's nobody else that's going to be doing this. Fine, that's fine. Move inventory can be called in a trillion different ways. How can you predict that? And likewise, think about it, allocate inventory. Allocate inventory is called a lot of different ways by allocate wave, allocate pick group, just a ton of things. If you try and predict how that's going to get called, rather than waiting to see what's going on, post conditions are more concrete, easier for us to do things with, and create a much more stable environment for the most part. Pre-triggers are handy for situations where you need to get in there ahead of things and you know exactly what the condition is that you're aiming for. So in this section, we should have a good idea of how to create a command, the kinds of different things, local syntax, and C components. You should understand how to create wrappers and triggers and the levels and the things to consider when looking at either writing wrapper or trigger logic.